How you doing in here, Mr. Perry? Doing good?
Good. Yes, sir.
You had calculus before?
No, sir. This is my first time.
Well, I hope I have helped you out tremendously. You know, let me tell you, there are some teachers that can lobotomize you. I hope I'm not one of them, but
You
there are
better.
some. Have you heard or you got friends in other calculus classes?
Oh, yeah, Dr. Anzer.
How are they doing in there?
Uh, not the best as far as his online exams go, but I mean, he knows what he's talking about. Like, just the
Yeah, he
delivery.
knows what he's talking about, but a lot of people say he can't convey it. I don't
No,
know. I've never heard it.
I
I mean,
had him for Trig. He wasn't. I,
um, what are they doing in there right now? Do you know?
at this point, they're probably doing identities right now,
Yeah, I
probably.
think they probably are they doing trig or calculus?
Uh, they're doing Trig right now.
Well, I know I skipped over a section, so I know they're probably not doing what we're doing because I skipped over that one section. All right, so let's go ahead and this is 5.283/12. 5.283/12. And this question says, find the definite integral, and they want you to use definition of the definite integral, but we're not doing that. We're just doing the integral, the antiderivative. So we're going to do it just
Okay.
like we do it in 5.3. So the antiderivative from 3 to 7 of x squared minus 9
Oh,
dx. So here's the question. Well, I already turned that on. Evidently, I didn't. There's the question. And they're wanting you to do sigma and Riemanns, but we're not doing that. We're just doing the derivative, so the antiderivative. So that's going to be x cubed over 3 minus 9x evaluated at 3 and 7. So parentheses to the third power over 3 minus 9 times parentheses minus parentheses cubed over 3 minus 9 times parentheses. And of course, we all know that this is the evaluation symbol. That means subtraction. And we also know that this is a 7, goes here. And this is a 3, goes here. And that is basically the math. And let me see if I did this one. I don't know if I did this one or not. Nope, I don't think so. I was going to see if I already did the math. Nope. So let's do the math. So 7 to the third power. I guess that's 343, but somebody check me. 343 over 3 minus 9 times 7 is 63. That's 63 over 1 minus 27 over 3 minus 27 over 1. And I left them as fractions. I know that 27 over 1 is 27, and 27 divided by 3 is 9. I know that. I got a degree in running water and everything. I know that. But I'm leaving everything as a fraction so I can get a common what? Denominator. So the common denominator is 3. And that's going to be 343. 1 will go into 3 times. 3 times 189. Somebody check me. 3 will go into 3. 1 will go into 3. 81. And somebody needs to take 343. Somebody take your calculator and do 343 minus 189, please. 52.
I got 154.
Yeah,
I'm sorry, what?
154.
154. Over 3 plus 27 minus 81.
Negative 54.
And that's going to be 54. I got 108 over 3. Somebody give me a decimal just so we'll know. Round it to 2 places, please. 36.
Yeah, 36.
36 square units.
Should that not be 208?
Oh, me, don't, I've already started messing up. Thank you. So what's 208 divided by 3? Thank you.
It's 69.3 repeating.
69 point what?
3 repeating.
Thank you. Is this a test question? Yes. Now, do you do it? Is that the way they do it in homework? No. But I told you we were skipping all that. We were skipping Riemann and we were skipping, we're not skipping it. I showed you a little bit of Riemann, you know, the midpoint, the left and the right, and you find the average, you find the area of each and you multiply it by how many rectangles you got. That's Riemann, okay? And the sigma, we didn't go over sigma, but this is what you need to be able to do for the test. Okay? If you're going to come in the class, make sure you got your video on. Even those that show me your ceilings and your walls. That was 5.2, 83/12. 5.2, 83/12. And it is a test question. Well, the antiderivative, finding the antiderivative, yes, but not the sigma and all that stuff that they do in the homework. All right, the next one. And you could actually, and I'm going to show you this next week, you could take your handy-dandy calculator and you can actually do, let's see, what was that? Take f of 1, or y is equal, let me clear this and clear this, and that's going to be x squared minus 9, x squared minus 9, and enter. And of course, y'all know what it looks like. And you can actually, if I remember correctly, math, I believe it's integration. Yeah, there you go. And you can go from 3 to 7. And we've got x squared minus 9. You can actually, I'll show you a trick I learned in the war. You can actually hit vars, y variable function, and pick y1. and you don't have to retype it in. Y'all welcome. X and enter. Look there, it's a miracle. 69.3 repeating. Y'all are welcome. Now, should you put all your eggs in that basket and go into Calc 2 with just knowing how to do it on a calculator?
No.
They will own you if you try that. Okay? They will chew you up and spit you out if you try to go in there and do everything on the calculator. I'll just go ahead and warn you, because that's what I would do. Okay? I'm showing you that so you can check your work. That's what I'm doing. And if you get a chance, you know, if you run out of time on the test and you got 3 antiderivatives to do, I would highly suggest you use the calculator if the calculator does not ask for the setup. A lot of calculus teachers will put the setup questions on it because some of our students that try to get over, they use the calculator too much. Let me turn on the large gallery. We've got more than 9 people in here now. We got 11 people, and let's see how many videos we got. There we go. Y'all are doing so good. All right, so I showed y'all that, so you feel good about yourself. And I'll do another one here in a minute just to let you get used to it. And what did we get? What was the, was it 208 over 3? Somebody help me out, was it?
Yeah, it was.
I done threw it over there. Okay, so that's a test question, and we did not do it with the sigmas and the Riemann, and I just did it. Next question. 5.3648. 5.3648. First of all, is it a test question? Yes, it is a test question. F of x or y is equal to 100 minus x squared. I feel like we've done this one. Y'all tell me if we've done it or not, but I think we have. What's the first thing you do with antiderivative? Somebody tell me what I told you. What's the first thing you do? Especially if you don't know anything. This problem here, you don't know anything. Okay, I'm not talking about substitution. Somebody said rewrite. Well, that's what substitution. This is not substitution. This is just, you got a function here, and they want you to find the antiderivative. What's the first thing you do when you're given a function and you don't know what else to do? You always do what with it? Always do what with it?
Draw a graph.
Draw a graph.
Yeah.
And we know this one is a solve for x. So 0 is equal to 100 minus x squared. X squared is equal to 100. The x-intercepts are positive and negative what? 10. Negative 10, positive 10, and it's a negative parabola. We know that this top area up here is 100 also, or this up here. So there's our, so this is f of x. F of x is equal to negative x squared plus 100. And where are we going to go from? What's our parameters?
Negative 10 positive.
So negative 10, positive 10 of x squared plus 100 dx. That's one way to do it. What's another way to do it? Remember we did this. We went over the 3 ways to do it. What's another way? There's 2 more ways. That means I want y'all to talk. I want y'all to communicate. Come on, y'all can do it. People have turned off their, have people turned off their videos? We had 15, now we only got 12. Eight, 9, 10, 11. 4 people have turned off their videos. Why are y'all doing that? I don't understand y'all. All right, what do you do? What give me another one. Somebody. Which way do we read?
Left to right.
So negative 10 to 0, negative 10 to 0 of a negative x squared plus 100 plus 0 to 10 of negative x squared plus 100. Sometimes I love ceiling fans, but sometimes I hate ceiling fans. Okay. Question. What's the third way?
To multiply by 2.
Thank you. I know that was painful. 3, multiply by 2 from 0 to 10 of negative x squared plus 100. There's 3 ways to do this problem. Now remember, if it's symmetrical around the x-axis, that means it's even. It's an even function. And it's very simple to do an even function like this and multiply by 2 because it's symmetrical around the x-axis. So let's finish it. I'm going to do this one. I'm going to do the bottom one because that's the one you should do because it's real simple. So antiderivative 2 times antiderivative 0 to 10 of negative x squared plus 100 dx. And what is the antiderivative of negative x squared plus 100?
Negative x cubed over 3 plus 100x dx. Oh, wait, no, not dx.
Now you already used up that dx when you took the antiderivative. At 0 and 10, and you're going to multiply all of that by 2. And what's the good thing about 0?
Cancels everything out.
That sounds like a good country song. What's the good thing about 0? All right, 0 will actually cancel out everything. That's actually a jab at so-called country music today. Country music today is a freaking joke. That's all I'm going to say. Anyway, you just go down the road and make a song about a rusty mailbox. So I'm going to make a song about 0, and it'll be a country hit. All right, so the 0 takes out everything, and that leaves 10. So negative 10 to the third power over 3 plus 100 times 10. To negative 1,000 over 3. Y'all check me. Last time I checked, 10 to the third is 1,000. Plus, what's 10 times 100?
1,000.
There you go. And of course, this is going to be 3,000 over 3, 2,000 over 3, 4,000 over 3. Somebody give me a decimal, please. Mr. Adamson looks like he's on some kind of radio station. And Mr. Vienna also. I'm gonna get me some of those earphones so I can look like I'm on a radio station. Or I'm on Facebook, you know, one of those, what do you call them things when you act like a radio station? What's it called? Podcast? That's what I need. I need Hubie's podcast. Oh man, I'd get taken off of Facebook. 4,000 divided by 3.
1,333.3.
1,333.3. Now let's check our handy dandy calculator. Since I'm introducing the calculator into the fold. Here we go. Clear, clear, clear. Y is equal, clear, and negative x squared plus 100. And graph, and I really don't care about the graph because we already did it, but you can do it, you can do mode or zoom standard, that usually takes care of it, or zoom fit 0. There we go. And we know it's negative 10 to 10, so we can go to, well, I don't forgot what we go to, math, function integration from negative 10. And the reason I'm doing negative 10 to 10 is to show you that you can do it any of these 3 different ways and you can get the same answer. Now, I'm not going to retype all that in. I'm going to hit bars and go to function and hit Y1 because I already typed it in the Y1 graphing function. And then dx. Look there, it's a miracle. Now I'm going to go ahead and say the disclaimer one more time because we had a few people come in. If you think you can go into second variable calculus and just use the calculator, they will eat your lunch. Okay? Because they will put problems on the test that do not use the calculator. And it'll make it much difficult for everybody else. So, why should you use the calculator? In an extreme emergency, like on a test and you're running out of time, or you're checking your homework or you're checking your work, that's when you use calculator. Okay? All right, let's go to another problem. And you can fill all that in. I'm not doing all that. Next question. Let me delete these 2. And that's another question just like it. 5, 4, 33, 6. 5, 4, 33, 6. 5.4, 33 / 6. Is this a test question? Yes. No. Well, it could be because you just do integration with one extra step. All right, I'm going to write it out while y'all are writing it. What is the average distance? What is the average distance between y is equal to 10x times 20 minus x and the x-axis from 0 to 20? I don't know why they wrote it like that. Why didn't they just write it y is equal to 200x minus 10x squared? Why did they write it like that? I'm going to write it y is equal to 200x minus 10x squared from 0 to 20. All right. Now, I didn't go over this in class, but I'll tell you right now what you do when you want to find the average distance. Okay? I'm going to draw average distance right here. And I'm going to color it. I'm going to highlight it. Hold on just a second. I'm going to highlight this pink. Average distance, you take your area and you multiply by 1 over b minus a. That is the average distance. So you do your integration just like you've been doing, and at the end you multiply it by 1 over b minus a. And of course this is b and this is a. So whatever our area is, we're going to multiply by 1 over 20. Everybody with me? It's not that big a deal. The only reason I say it could be a test question is because you got to find the antiderivative, and that's why I would put it on the test. So, antiderivative from 0 to 20 of 200x minus 10x squared dx multiplied by 1 over 20. There you go. All right, do it. Give you a minute to do it. So 200x squared over 2 minus 10x to the third over 3 evaluated from 0 to 20. And then after you do all that, find the area, you multiply that by 1 over 20. Now, what does 0 do? 0 cancels out everything, so you don't have to worry about 0. So 1 over 20 multiplied by 200 times 20 squared over 2 minus 10 times 20 to the third power over 3. And that's going to be 1 over 20. What's 200 times 400? 8,000. Help me out there. Is it 8,000 or 80,000? Let's see how many zeros. There's 2 zeros here, 2 zeros here. 80,000.
80,000.
Yeah, I had to count the zeros. Minus, what's 20 to the third power? Dang old 800 or 8,000? Be 8,000, wouldn't it? And then another 0 would be 80,000
That's 8,000.
over 3, right? Now you just got to get common denominator, which is 6. So 1 over 20, 80,000 over 2 minus 80,000 over 3, 6, 6. 3 times 80,000 is 240,000. 2 times 80,000 is 160,000. 240,000 minus 160,000. What is that? 80,000? Somebody help me out. Divided by 6, multiplied by 1 over 20. Well, that 20 will take one of those out, and that 2 will take that to a 4. Somebody check me. 4,000 over 6. And then that would be 2,000 over 3. I need somebody to check my math for me.
Priority 1 message coming in on secured channel.
What's 2,000 divided by 3? Ain't that 13, 33, 33, whatever?
That's it.
So there it is. Should be your answer.
2,000 divided by 3 is 666.6.
Okay, 666.67. Yeah. I'm sorry. That's the answer. 666.6 repeating. Now, the reason this is a test question is because you should be able to do this and multiply by 1 over 20. What was that? Somebody just hear a beep? Is that
I
not-
did.
I heard it. I don't know what it was. But
Okay. This is why I'm going to take my handy dandy green marker. This is why this is a test question, because this is something that y'all can do. This is extra. This right here is the only extra thing to it. And if you can't multiply 1 over 20 by something in calculus, you don't need to be in calculus. Okay? So that could be a test question. 5, 4, 33, 6. Next question. And let's type in 666.67. Of course, they want a fraction because they don't want that. Let's see if they get 2,000 over 3. Oh, I'm sorry. But they'll take 666 2/3. Dang old Antichrist. All right. 5.5, 59/19. 5.5, 55/19. Now, this one is kind of out of its element, but we'll go ahead and do it. It's kind of, we haven't covered one like this. So it says the antiderivative from 1/3 to the square root of 2 over 3 of dx over x square root of 9x squared minus 1. And you're going to need your sheet with the inverse, the integration of inverse trig functions. So I'm going to go pull that up under your file page, which y'all should have it beside you because, you know, you're the one taking the test. Derivatives of inverse trig functions or integration. Either one, it should be on there too. Okay, I didn't give you those. I thought I did. Well, you can use the, hold on a second. Let's go with the derivatives and see. Derivative of inverse trig function. Yeah, there we go. All right, here you go. Now, which one does yours look like right here? Which one does yours look like? You got that right there. Well, let's see. You got a square root, so it's not tangent and cotangent. Everybody understand that? It's not tangent or cotangent. Why isn't it sine and cosine? Somebody tell me why.
There's no x in front of the square
There's
root.
no x in front, so it's got to be secant or cosecant. Which one is positive? So the antiderivative of this is secant. So secant, this is equal to inverse secant of x. Okay? So that's where I get the secant. When you see the secant here in just a second, that's where I get it from. Now you can pull up integration. Let me do that for you right quick. If you want a handout with integration, all you got to do is just look it up. Integration of inverse trig. Hit images. And let's see. There we go. That's the same thing. That's the same thing I put on y'all's sheet. Well, there it is. Same thing. All right, so with that being said, what do you do next? Well, you need to see where all your parts are. First of all, u is equal to 9x squared minus 1. U is equal to 9x squared minus 1. Therefore, du is equal to 18x dx. Well, we can't get 18x dx because x is in the denominator. So what do? We can't multiply. We can't do this. So let's look. We know that this can be rewritten. And that's what I would tell you to do when you see one like this. Rewrite, because this don't work, because I can't get an 18 dx with 18x dx with the x being in the denominator. Can't do that. So that don't work. So I got to rewrite it. I'm going to rewrite it, and I'm going to do 1/3. Sorry, hold on. 1/3 to the square root of 2 over 3 dx x square root Did everybody see what I did? Oh, I'm sorry.
So I do a thing up below, please.
There you go. What did I do? Since this didn't work, and I'm going to put a big pink X there, since our Substitution didn't help us out too much because we can't get 18x with 1 over x. That's going to be hard to do, so that's not going to help us. Then I go back and I go to rewrite. And I rewrote, and what did I do? I want somebody to tell me what I did, so hopefully it'll stick with some of y'all that, you know, doing this for the first time. What did I do?
Didn't you basically substitute?
I rewrote this in terms of quantity what? Squared. So now I have this and this. Go back to your handy dandy. And somebody tell me what I just found. I found x. X is equal to what? 3x. I just found x. 3x right there. So x is equal to 3x. So now I'm going to do u substitution with 3x. U is equal to 3x. Therefore, du is equal to 3 what? dx. And I can do that. So I need to have a 3 dx. I've only got a blank dx. So what I need to do, put a what here?
Yes.
Put a 3 there and a 1/3 out front. And now I have du over u square root of u squared minus 1. So 1/3 antiderivative from 1/3 to square root of 2 over 3 du over u square root of u squared minus 1. And that's basically equal, this is equal to the secant. And you can plug the u back in. It's going to be 9x squared and plug and chug. Like I said, it's kind of out of our element. I'm not going to, this is not a test question, but it does show you how to rewrite. This is the one thing I want you to see right here. Rewrite, since this didn't help us, rewrite this as 3x to the second minus 1 to the second, and there's your x right there. Or in this case, it's going to be your u, and then you get that 3, and you can take off from there. Okay? So secant, inverse secant of 9x squared minus 1. And it's going to be absolute value, but not a big deal. All right, let's move on to more test questions. I'm trying to cover all these homework questions that are test questions. That's why I'm not trying to hurry. I'm just trying to get them all done. All right. That was that one. That's both of those. 5.56/3. 5.56/3. 5.56/3. If the change in variables is u is equal to x squared, u is equal to x squared, is used to evaluate the definite integral from 3 to 9 of f of x, what are the new limits? What is your upper limit and your lower limit? They just want you to change it from 9 to 3. If you change this to the antiderivative of u, then what are you going to do with the two? What are these going to turn into? We did this yesterday. We did this last couple of days. They just word it to where you don't know whether you're going, up or down. So what's the bottom one going to be?
9.
9.
That'd be 9.
3 squared, which is 9. And what's the top one going to be?
81.
Yep. So since you're changing the U, it would be from 9 to 81. And yes, this is a test question, but I'm not going to give you one that easy. I'm going to make you do an antiderivative with it. The new lower limit is 9. Excuse me. 3. Oh, why did it change? Did y'all see that? Was it x squared or was it x squared minus 8?
I think it was x squared minus
I think it was all.
Okay, I didn't see it. All right, x squared minus 8. Let's do it again. I'm sorry. I thought it was x squared. So what is 3? What is 9 minus 8?
1.
And what is 81 minus 8?
73.
73. So this one will be 1 and 73. Kind of helps to read the, question, doesn't it? That's a test question, and if you miss it, don't tell anybody because that's embarrassing, especially if you don't read the question. Next one, same type. 5.5, see, let's just see what it is just so you can get extra practice. U is equal to x squared plus 1, and we need to change 3 and 7. So what is the new lower limit going to be? That means I want somebody to say something.
10.
Where are you, Mr. PL? Are you in a closet somewhere?
I'm in a lab.
Or did somebody kidnap you?
Both.
Okay. And what's 7? What's the new upper limit?
50.
And that's it. Maybe I ought to take those out of the homework. Take them out of the test. Those are too easy. Somebody will miss them. Anybody want to bet me? 5,
No, I do
5,
not.
73, 20. 5, 5, 73, 20. Okay, the antiderivative from 2 to 3 of 7 over 4x squared plus 8x plus 4. I don't think this question is correct. I think that's supposed to be a 4 on top. Because I've tried to do this problem and I can't get it to come out right with the way they're doing it. But I'll go ahead and show you how you're supposed to do it, but I can't get their answer. So there's the question. The first thing you want to rewrite, denominator. Rewrite the denominator. How can you rewrite the denominator? Well, it's a shortcut. Shortcut number what? Number 1. So it's going to be 2x plus 2 quantity squared. So from 2 to 3, 7 dx over, I don't forgot what I just said, 2x plus 2 quantity squared. So u, somebody tell me what u is going to equal.
2x.
Therefore, du is going to equal what?
Seven.
What's the derivative of 2x?
2.
Now, this is where I think they're wrong. I believe this is supposed to be a 4 or 2 because there's no way to change 7 into a 2. You're going to have to multiply 7 by 1 or 14. I'm sorry. You can't. You're going to have to divide. I'm thinking. Let's see, where did I do this problem? Is this problem, do I have it? Yeah, here it is. Yeah, I don't know how to get 7 to look like a 2. So, and I just did exactly what they did. U is equal to 2x plus 2. And they changed the 2 and 3. I understand that. But I don't understand where they got this. Because I don't understand where they got the 7 halves. Because even if you multiply it by 2 over 7, 2 over 7, that's how they did it. I just now noticed it. 2 over 7. So that means you're going to multiply by 7 over 2. That's how they did it. I just saw it. What's 2 over 7 multiplied by 7? That takes it out, makes it a 2. So I multiply by 2 sevenths here, multiply by 7 halves. So that means I'm going to multiply 7 halves right here. And I'm going to get a 2 dx right there. So that means I've got 7 over 2 antiderivative. And we can go ahead and change this. 2, that'd be 6, wouldn't it? 3 would be 8. Y'all check my math. Of du over u squared. Which would give you 7 halves antiderivative from 6 to 8 of u to the negative 2 du. And now you've got power rule. 7 halves times u to the negative 1 over negative 1 evaluated at 6 and 8. Well, I can clean this up. Negative 7 over 2u evaluated at 8 and 6. Negative 7 over 16 minus negative 7 over 12. Y'all check my math, please. And the common denominator for 12 and 16, 2, 6, and 8, 2, 3, and 4, 3, 1, and 4, 4, 1, and 1. 4 times 12 is 48. So we've got 48 as the common denominator. Negative 7 over 16 minus negative 7 over 12. Common denominator is 48. 16 will go into 48. 3 times 7 is 21. That becomes a plus. 12 will go into 4 times 7 is 28. Negative 21 plus 28 is 7 over 48. And that should be your answer. We can actually check that. So let's go to our calculator and type in y is equal to, clear. And our problem is 7 divided by, parentheses, 4x squared plus 8x. I hate these calculators. Damn Russians. 4x squared plus 8x plus 4. Graph. And there it is. And I really don't care what it looks like. Zoom standard for 6. Okay, and they want to know from the area under the curve. So that's going to be math, derivative, or antiderivative. And we're going to go from 2 to 3. And we're not typing all that in. We're going to go variable, function, y1, and then dx. What did we get? 7 over 48. Somebody give me that decimal. What is 7 divided by 48? That'd be like 1/7, wouldn't it? What's 7 divided by 48?
0.14.
I'm sorry, what?
0.15.
0.15?
Yeah.
And let's see what they get. It's a miracle. I bet y'all, some of y'all didn't know how to do it on a calculator, did you? You're welcome. Don't abuse it. Next question. 7 over 48. Delete. I don't know what that is. AR 851. That should be just a graphing on your handy dandy calculator. Well, it's not coming up. I'm not going to worry about that one. Yeah. Use the graph log. Okay, log of x over log of 3. And then this one, log of x over log of 3 plus 5. and you should see a vertical or a horizontal shift. Just do that on the calculator. So go back to y is equal, clear, and I'm going to type in, what is it? Log of x over the log of 3, because you can't type it in any other way. So that's going to be log of x, parentheses, divided by log of 3. Close parentheses. And that's that graph. And now it's going to have a vertical, or it'd be a vertical shift of 5 up. Now they want you to do the same thing. Log of x over the log of 3 plus 5. So I got to put the log of x and the log of 3 in parentheses. So y is equal to parentheses, and same thing that I just typed in, log of x, close parentheses, divided by log of 3, close parentheses, plus 5. And that should give you a vertical shift. There it is. So you basically got a vertical shift of 5. All right, that's all the homework questions. Aren't you happy?
A little bit.
All right, we got some few minutes. Let's go over some problems that I pulled up. Homework problems. Area between two curves. Finish out this class today. You didn't think y'all was going to get out easy, did you? All right, so here's one. F of x is equal to x squared plus 1. And g of x is equal to x. And we want you to go from 0 to 1. All right, do that. You don't have to find where they intersect. I've given you that right here, 0 to 1. So you're going to go from 0 to 1. Go ahead and graph it so you can see what it looks like, so you can know what to subtract from what. I'm going to let y'all work on it. Get me something right. Yeah. So when you graph this one, and you can sketch it without using your calculator. We're going to do this one in blue. And And we'll do this one in yellow. So x squared plus 1 has a y-intercept of 1. So that means that's where it's got a vertex. And y is equal to x. Looks like this, 45-degree angle. And they want you to give them the area from 0 to 1. So they're wanting this area right there. That's what they're wanting. So we all know that f of x is the dominant one. So that means that we're going to take the antiderivative from 0 to 1 of x squared plus 1 minus x dx. So that's going to be from 0 to 1 of x squared minus x plus 1 dx, x cubed over 3 minus x squared over 2 plus x evaluated at 0 and 1. And of course the 0 still takes itself out. So you're left with 1/3 minus 1/2 plus 1 over 1. And 6, 6, 6. 3 will go into 6. 2 times 1 is 2. 2 will go into 6. 3 times 1 is 3. 1 will go into 1. 6 times 1 is 6. 2 minus 3 is -1. Plus 6 is 5 what? So that area is equal to 5/6 square units. And somebody tell me what the decimal is 5/6. 5 divided by 6.
0.83.
Point what? Sounded like you said 0.83. Sounded like
0.83.
you growled it. 0.83. So I assume that was 0.83. Got to realize these microphones are not the best in the world, so you have to articulate. Instead of saying 0.3, say 0.83. You know, like those people that say the car is parked in the yard. Okay? So you need to speak like that. So let's go to our handy dandy now. Somebody tell me, what do we type into the calculator? Well, you're going to type in the setup in the calculator. Here's the setup. That's what you're going to type in. So take your handy dandy calculator, clear it, type in the two functions, y is equal clear and clear. First function is x squared plus 1, x squared plus 1 And the second function, since we did yeller, I'm going to change it to yeller. And that's going to be X. If I could ever get there. There we go. Graph. And we're going to find this area right here from 0 to 1. So I'm going to hit math, down to integration. And I'm going to go from 0 to 1. And I'm going to type, oh shoot, I typed in the wrong thing. Let me go back and, well, I can just type it in here. I don't have to do that. So math, integration. Oh no. Like I said, I hate these calculators. Now let me go back. Math. Let me just quit. There we go. From 0 to 1. And I'm going to type in my setup because I had to subtract the two from each other. So that would be x squared minus x plus 1. And dx. And 0.83 is what we got. Look at there. 0.83. Don't y'all feel like y'all are just learning so much in here?
Well, we are,
Say again.
because we are.
I tell you. All right, here you go. I'm going to do y is equal to x squared in blue. Now you're going to have to find the endpoints on this one. And yellow is y equal to negative x squared plus 2x. You're going to have to do everything on this one. So there you go. Give y'all a minute or two to work on that. You got to find, first of all, you got to graph it or sketch it. Then you want to find the intersection points. And then set up your antiderivative. So our function blue function is going to look like this. And our yellow function is going to look something like this. And this is the area we're wanting to find. So x squared is equal to negative x squared plus 2x. 2x squared minus 2x is equal to 0. 2x, x minus 1 equal to 0. And 2x is equal to 0. X is equal to 0. X minus 1. So there is your parameters from 0 to 1. And the setup, antiderivative, from 0 to 1. Which one's your dominant for your region? Which one is your dominant, yellow or blue?
Yellow.
Yellow. So at negative x squared plus 2x minus x squared, you always subtract f of x minus g of x. Antiderivative from 0 to 1 of negative 2x squared plus 2x dx. And that is your setup. Okay, finish it out. So we got to take the derivative. So that's going to be negative 2x to the third over 3 plus 2x squared over 2. And of course we see that the 2's cancel. So negative 2/3 x cubed plus x squared evaluated at 0 and 1. 0 takes itself out. So all we have to do is plug in 1. Well, negative 2/3 times 1 is negative 2/3 plus 3/3. Area is 1/3. So let's check our setup on the calculator and see if we get 0.33. So I'm just going to go, I'm not going to worry about graphing it. We already graphed it. And plus, when you subtract, you need to actually, since I've subtracted, I've got to punch that in. You could do parentheses and do a minus and then do, yeah, we could do that. Let me show you how to do that. Y is equal to negative x squared plus 2x, negative x squared plus 2x. I just established which one. Oh, Lord. Hold on. X squared plus 2x. And I just established it got a times and a plus in there. I don't know why that's in there. I'm about ready to scream. No, I don't really want to do that this afternoon. I want to teach. It's aggravating me. All right. And then x squared. And I got them backwards, so I need to fix that also. So that's blue. And this one is yellow. The reason I put that one first is because that's what I'm going to subtract from. And that's why I wanted to put it first. Now I'm going to show you how to do it as far as subtracting. And you don't have to do it by algebra. So math, integration. Now watch what I do here. Why did it go there? It's not supposed to go there. Second, quit. Second, quit. Clear. Let me try that again. Math, derivative, I'm sorry, integral. I think I just might as well just quit. It's the third time I've tried this. All right, 0 to 1. And watch what I do here. I type in f of or y1, go to variable, y variable, function, and y sub 1, and I'm going to subtract y sub 2, variables, function, and I'm going to subtract the second one, and dx. And we got 0.3333, and that's what they got, 0.3333. All right, I'm going to do one more because I'm going to stay. Now, let me go ahead and tell everybody, if you are going to self-combust and blow up, then go ahead and leave. Let me get the roll right quick and see if there's any names missing. But I'm going to go until 1:30 because I want to get all this in I can for the weekend so y'all can be working on homework. So let me call, see if there's anybody left that hadn't attended this week. I'm not going to turn the recorder off because we're not going to mess up everything. Only name I need is Miss Diaz. Is she here? Yep. Miss Diaz is here. See if there's another name. Vienna is here. So everybody's here this week. Okay, so I'm going to keep on going. I'm going to do one more problem. I want y'all to work on it first. And this is, we'll make the blue one y is equal to 3x plus 5. And the yellow is going to be y is equal to negative x plus 3. And we're going to be going
Priority 1
from
message coming in on
0
secured channel.
to 2. So I'm not, you don't have to, from 0 to 2, I'm giving you the lower limit and the upper limit. All right, go to it. I want you to sketch it. I want you to set up the equation, because you don't need to algebraically find the intersections. Good God, people, it's just one question. You think all of them were dying of exhaustion. Everybody's acting like they're got to get out of here. So let's see, 3x squared plus 5. That's going to be a parabola opening upward. One, two, three, four, 5. It's going to be skinny because of the 3. And then you got negative x plus 3. Well, hell, that ain't going nowhere near the parabola. So 1, 2, 3. And they want to go from 0 to 2. So from 0, 1, 2. So they want this area right in here. All right, go to it. So antiderivative from 0 to 2 of 3x squared plus 5 minus negative x plus 3. And 0 to 2, 3x squared plus 5 plus x minus 3. Zero to 2. Well, oh, okay, 3x squared plus x plus 2. 3x to the third over 3 plus x squared over 2 plus 2x evaluated at 0 and 2. 0 takes itself out. So that's going to leave you 2 cubed plus 2 squared over 2 plus 2 squared, 2 times 2. 8. 4 divided by 2 is 2 plus 4. And I got 14. What'd y'all get? Yes, no, maybe.
I got the same.
And those are 3 or 4 good test questions we just did that could be on the test also. Alrighty, guys. What y'all are responsible for, same as the other class. Everybody is responsible for 5.1 through 5.5 and 6.2. I haven't decided. I'm probably going to break up this test into this and then the rest of chapter 6, but I don't know yet. But I want everybody this weekend working on 5.1 to 5.5 and 6.2. Questions, gripe, complaints? All right, y'all have a good weekend. So also the 143 class. Have a good weekend, and I will see y'all Monday.
You too. See you Monday.
See ya.